come. So we've got the recording started. And I mentioned this in the email, but we're going to spend the first like 30-ish minutes, or however long it takes. If it takes us less time, that's fine. But I'm anticipating it will be about 30 minutes to go over the second conjecture. And then after that, I'm going to help anyone who wants more help on the week one conjecture and like to actually go through like how to write out the proof for that. So that's kind of the plan or the schedule for this office hour. So if we look at the week two conjecture, let me share my screen so we can all look at it. Okay, so this conjecture is all about exponents. So as a quick review of what exponents are, if you have some number, so I've called it x, and you raise it to an exponent of a, that means that you multiply x by itself a number of times. So like if you had 2 to the third power, that means you're doing 2 times 2 times 2. So hopefully that is familiar, but that's just the definition of what an exponent is. And what we want to look for is we want to look for a rule that determines when you multiply two powers together, how you could simplify that to be whatever the number is you're raising to an exponent, raised to an exponent instead of having like two numbers raised to exponents multiplied together. So has anyone played around with this and come up with a conjecture for what they think this might be for the first one? You can put it in the chat if you've got. Oh, Amy, I saw your hand. Yeah, go ahead.
I don't type very fast, so
No worries.
I just did x to the a plus b.
Okay.
Oh, but I have to say it in words. So I just said hold on, I have to say it in words. When you have two exponents with the same base that are multiplied by each other, the product is always the base to the power of the sum of the exponents.
Right. Yep. And we could write it in algebraic notation, like you mentioned earlier, and say that this is x to the a plus b power. Now, did you figure that out from examples, or like how did you figure out that that was what x to the a times x to the b would be?
Well, two ways. I already knew that one. And
Okay.
but then I used the examples. I just used real numbers for, let's see. I have to remember it was real numbers. No, it's counting numbers for the exponents, and I used integers for or real numbers for the x value. So
Okay.
then I just plugged them in. I just did a couple of examples to help me remember, and that did help me prove it as well,
Mm-hmm.
because I could see my steps.
Okay, perfect. Do you have those examples handy? Could we write them out just so that everybody's kind of on the same page of how you figured that out?
Sure. So example one, I said if A equals 2 and B equals 3 and X equals 5, then that's what I used for my example. So 5 squared times 5 cubed, or 5 to the third power, should
Mm-hmm.
equal 5 to the 2 plus 3 power.
Mm-hmm. Which in this
Or
case, since we know what the numbers are, we could say it's 5 to the 5th.
yeah, yep, we could.
Perfect. Yep. And if we were to use the definition of exponents that we were given, we could show that because we'd say 5 to the second power is 5 times itself twice. So that's like the first exponent power. And then 5 to the third power is obviously 5 times itself 3 times. And since multiplication is commutative and associative, basically that's just 5 times itself 5 times, which is where that 5 to the 5th comes from. Does anybody have any questions on that?
I do when you're proving it. So at that point, is that how you say it? You say, because it is Associative, meaning you can associate the ones that are, you can say 5 times 5 in a group, and then 5 times 5 times 5 in a group. If they're multiplied together, that means you can bunch them together, just saying all of them multiplied together because of, is that the associative property? Because they can associate.
I don't, I'm actually, because the associative property says that like it doesn't matter, like if you have like three numbers you're multiplying, it doesn't matter if you multiply these two first or these two first. And then the commutative property is the one that says you can switch the order, that like 3 times 5 is the same as 5 times 3. So I would say this is probably the associative because like these parentheses are saying that you group them and you
Into
multiply
two
these
groups.
2 5s first and then the 3 5s. I don't really care too much if you guys are like super stickler on like naming those because we all know how multiplication works, that you can rearrange the order, you can multiply it in any order. The main thing I want you to do though, so what we've done here is a proof that shows that 5 squared times 5 to the third is 5 to the fifth. But what we actually want to prove is that any number to an exponent times any number to an exponent equals that base number to the sum of the exponents. So we want to prove it generically, not just for the examples of a equals 2, b equals 3, and x equals 5. So the process is going to be very similar, but we want to prove it generically for all exponents. So would it be helpful for you guys if I actually like typed out what this would look like what that proof would look like? It might take me a little bit of time, but I think that is maybe like where the, I guess, most challenging part of the assignment is. So I'm happy to do that if that'd be helpful. Let me clear my annotations. Do that.
Can I ask a question
Yeah, go
about
for it.
this? Okay,
Mhm.
so on mine, I got to I'll just read the the last couple of sentences. I said, because the base is the same and it's represented by x, and
Mhm.
x is multiplied a times and then b times, I was like, therefore, by the definition of the law, or it's like the law of exponents, right? That says that whenever you have those two together, that you end up adding them. So we can't use that as proof, like we're trying to prove the law of exponents.
Yes.
Okay,
Mhm.
got you. Thank
Yep.
you.
Yes. That is a great question. Thanks for clarifying that. Yeah, so each one of these three things are laws of exponents. And so we are trying to prove why they always work. Okay, so whenever you're starting to prove a conjecture, the first thing you want to do is to state what your conjecture is. So the way that you would do that in this case is we'd say, okay, our conjecture is that you'd like type in the equation. So I actually realize this might be a little bit harder because exponents are hard to type. Are you guys okay if I like type it in this notation just for speed? Like I know that there's equation options, but it'd be faster just actually. I think I can write it. Let me write it out on my iPad. That might be better actually. Because then the notation actually looks right. And by the way, guys, you are welcome um to, oh, that's the wrong thing I shared. You are welcome to write out your proofs by hand, like if it's too clunky to use the notation. Last week, that wasn't as much of an issue, but like if you don't want to have to be like, oh, insert equation, add exponent, like to have it typeset, you're welcome to just write it out by hand as long as it's legible and I can read it. Okay. Were there any questions so far before I start writing out the proof? Delaney, yes, that's fine. But just make sure if you do that, that it's really clear what's in the exponent. So like, if you were writing out our conjecture, so since we need to do this anyway, I'll write this out. So our conjecture is that x to the a times x to the b equals x to the a plus b, regardless of what numbers are x, a, and b. So if you were writing it out or typing it with like the exponent tool, you could write it like this. But if you're using those little caret symbols, what it would look like is you'd have x caret a and x caret b. And to make it clear that you're multiplying these, you'd want to like put parentheses around it. So it's like this is multiplied by this. Because if you didn't have the parentheses, it would look like maybe a was times by x in the exponent. So you'd want to like, I guess, kind of like overuse parentheses to make it really clear what you're trying to say if you use that notation. Sorry. I think I hit a button and it made it stop sharing. Redo that. Does that answer your question about the typing piece? Okay. So going back to our proof. So we've got our conjecture is that x to the a times x to the b equals x to the a plus b. So this is going to be a equivalence proof because we're trying to show that like the left-hand side of the equation equals the right-hand side of the equation. And to do this, you just use the definition of exponents. So why is my, oh, hopefully this works. I don't know why it keeps. Sorry, I didn't know that this was going to be an issue. Be really careful not to touch any buttons. Let's do that. We'll do it. So the way that you would start off the proof is you'd say, by the definition of exponents. I apologize that my handwriting isn't the best. Which was given in the project guide, like what an exponent is. We can say that x to the a equals x times x however many times, and this is a times. So that is like the best notation I can use to describe what an exponent is. And then x to the b is the same thing, where you have x times x however many times b defines. Is everybody good with that so far, how I've used those? And then we can say, therefore, or if you want to set it up as like a left-hand side, right-hand side proof, you can say the left-hand side and like do this in the left-hand column. But we would say that x to the a times x to the b equals x times x a times and x times x b times. And then you would like explain in words, because we are multiplying x by itself a times, and then b times the total number of dang it. Not ideal. If it does it again, maybe I'll switch to typing it, and we'll just do it that way. The total number of x's that we're multiplying is a plus b number of x's. So like a plus b is expressing the number of x's that we're multiplying. So x to the a times x to the b equals x times x. And the number of times is a plus b times. So again, like I'm kind of going from this like expansion of the exponents, then I'm explaining that since we're multiplying a x's together and then b x's together, the total number of x's is a plus b. And then I would go back to using the definition of exponents, and I would say by the definition, I'm almost done. I'll say it out loud and then. We'll do the next one with typing because obviously this is not working very well. So by the definition of exponents, oh, it stopped again. Basically, you'd say by the definition of exponents, this is x to the a plus b. And you'd say, therefore, the left-hand side equals the right-hand side. And so the thing is proved. Yeah, Amy, go ahead.
So Dr. Willis, when we do this, that's where I'd get stuck is why can I say that? So I can just just describe because it's combining, that's addition. And I don't know. I kind of felt like I was stuck in the weeds of how to say that and why I can say that. But I can just go ahead and say because we're doing an x a times and we're doing the b times, therefore it is a
Yeah,
plus
and
b times.
like if you want to explain that in more detail, you could say like multiplying x by itself a times means that I have a number of x's I'm multiplying. And same thing with the b. So if I have a number of x's I'm multiplying and b number of x's I'm multiplying, the total number of x's I'm multiplying is a plus b. That would kind of be the way that you'd explain that in more detail. Does anybody have any questions about that one? How to do that? Were you guys able to get the idea of how to write the proof, even though my iPad was being finicky? Okay, cool. So you have two other conjectures. You have x to the a divided by x to the b, and then you have x to the a, which is raised to an exponent of b. So the dividing one is semi-similar to the multiplying one. It's just that instead of like taking these ones and multiplying by these ones, you take the group of x's and divide, which means some of your x's will cancel out. So do you guys maybe want to do the third one? We can talk about that and what that proof would look like. Okay. So first of all, what is your guys' conjecture? And I'll share my screen and type this out this time. So go ahead and share in the chat, or if you want to hop on mic and share on mic, that's fine too. But what is the conjecture? Okay, awesome. So we've got x raised to the a times b. So this would be a situation where you would want to definitely overuse parentheses if you're going to use the little caret symbol. I'm going to use the actual equations though, because I want you to see like what the actual notation look like. So on these ones, it might be easiest if you write it out by hand rather than typing it, if you don't want to use the equation ones. But we would say that our conjecture is, if I have an exponent where I have an exponent inside of parentheses, so x to the a, oops, a, raised to the b, that this equals x. I have to type in the exponent thing. X raised to the a times b. Yeah, Delaney, we can totally do that. Yeah, let me finish this one since we've already started it. And then we can totally go over the division one. Okay, so on this one, again, it's an equivalence proof because we're showing that the left-hand side equals the right-hand side. So why don't you guys put in the chat, how would you expand x to the a raised to the b power? Like using the definition of exponents, how would you expand? Okay, perfect. Awesome. So essentially, you've got this x to the a. Where's my equation with my dots? Wish my iPad was working. That would make this a lot easier. And then like in little brackets, you would say this is b times. I can't remember how I typed it up when I wrote up the example on your guys's projects, but basically you would say that you're doing this x like b number of times, right? And then you can say by the definition of exponents again, so this expression can be expanded to be what? If we use the definition of exponents again, what would that be?
Would each of the x's have a b by it then? Is that what you're saying? Like it would be x to the ab when you expand it?
So it's more saying that the number of these that we're multiplying, so like I've got these little dots here, the number of those is b. So like if b was 5, it would mean you'd have x to the a times 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 x to the a, because you'd have that number of x to the a's being multiplied together. Does that answer your question or?
Yeah, thanks.
So you say, okay, like, you know, I've got b number of these things, but then this is also an exponent. So we had kind of this like outer exponent where we had x to the a times itself b times. But then we also have this inner exponent that can also be expanded. And we'd say that can be x times x times x. Oops. Like a number of times. So like each of those x to the a's can be expanded to x to the a, or like x times itself a times. So like if I've got a number of x's times a number of x's times a number of x's, b number of times, that like you would explain that that's going to be multiplication, because the number of x's you have in that long string of x's is b groups of a x's. So like treating just b and a as if they're numbers, it's saying that like you have this many groups of this other number. Well, groups of a certain number of things, like that's what multiplication is, because multiplication is equal sized groups. And so you would explain, because I have b groups of a x's and they're all being multiplied together, that's why. Or like, and well, I guess you'd actually make another line. So you'd say it can be expanded to this, because we have b groups of a x's multiplied, or multiplied together. The number of x's being multiplied in total is a times b, whatever those numbers are. Just because of the way that multiplication works. And so you can say, therefore, this expression equals x times x times lots and lots of x's, but the number of x's, so like if I remembered how to do braces, I'd have a brace underneath it, and I'd say that the number of x's I'm multiplying together is a times b number of x's. And then I'd go back to the definition of exponents to prove, or to say, like, by the definition of exponents, this expression having a times b number of x's is equal to that. Does that make sense? Delaney, yeah, you could totally do that. Yep. When you have an expression like this, it doesn't actually matter which way you expand it. It would be the same thing. Because if you expanded it in that way, you'd have a number of x's times itself, b times, which would still be b groups of a. So to recap, the things that are missing in my proof right now is that this should have a little brace underneath it that says that there's b of them. Each one of these should have a little brace underneath it that says there's a of the x's. And then this whole thing will say that there's b number of those sets of parentheses. And then this one should have a little brace under it that says that the number of x's is a times b. And then the last step would be just to show that having a times b number of x's multiplied is the same thing as this. Any questions on that? Yeah, Amy, go ahead.
So when we write that, if we type it up, because I have mine typed, could we, rather than have the brace, could we just have the word a times underneath, as best we can, underneath the parentheses, the group of a time? I don't know how to say that.
Or if you want to, you could also explain this in words. So I'm using the algebraic notation for it. You could say that I have x times itself a times. And then I have b of those. So if you want to explain that in words instead of notation, that would work as well. Yeah. Any other questions on this one? So someone else asked if we could go over the division one really quick. So for that one, what would the conjecture be? Okay, awesome. So we would have our conjecture is that if I have division with an exponent of x to the a and x to the b, that this expression is equal to x to the a minus b. So again, so like with all of these proofs, always go back to what the definition is. So if we want to prove that this left-hand side is equal to the right-hand side, what we need to do is we need to expand the left-hand side in a way that shows that by the definition of exponents, it equals this. So if I were to expand x to the a over x to the b, what would that expansion look like? I know it's kind of hard to type it into the chat, so no worries if it's a little bit funky. Okay, yep, so the top would be, maybe I'll just copy and paste this. So the top is going to have x times itself, and you're specifically going to have it be a times. And then Wonder if there's like maybe some type of substitute notation we could use for a minute. Maybe if I put, I don't like using parentheses because that also means multiplication, but maybe we'll just use that to notate what would normally be in brackets. So we've got x times itself a times, and then what would the bottom look like? Okay, awesome. So we've got this. Now, how do we go from that to showing that it's x times itself a minus b times? Okay, perfect. Yeah, and if we cancel out, and so we need to explain why it's justified to cancel out the x's. So that is what we'll do. And we need to justify it. So what's the reason, mathematically, why we can cancel out x divided by x? Perfect, Amy. Yep, exactly. So because x divided by x equals 1, unless x is 0, but we can just say x is not 0 because that will make that problematic if x is 0. Because x divided by x equals 1, however many pairs of x's there are that match on the top and bottom, those will cancel out. And I'm not going to type out the whole thing because I don't want to do your guys' like whole assignment for you, but you'd explain that reasoning of like how you could cancel out however many x's there are. And then you would say the amount of x's that are left. And on this one, you guys can just assume that A is bigger than B. I probably actually should have included that in the one because I don't want you guys to have to get into negative exponents. It actually does still work if you have negative exponents, but that's not something I want you guys to get into. So you can just say that A is bigger than B. And so all of the B x's, like the B number of x's is a smaller number of x's than the A number of x's on the top. And so all of the B's will cancel out, and the number of x's you're left with on the top would be A minus B. Okay, yeah, so they are going to be counting numbers, but on this particular one, again, it's true even if B is bigger than A. Like if A was 2 and B was 3, you would have x to the negative 3 power. But I don't want to get into that for this conjecture. So you can just assume that A is bigger than B. Perfect. Yep, that's great, Amy. So basically you'd explain that B of the x's will cancel out and the number of x's you're left with in the top is A minus B. So you would say like I have A minus B x's times a whole bunch of ones because that's what the x over x is equaled. So you'd have like A minus B x's times 1 times 1 times 1 B times. But again, like if you multiply anything by 1, it just equals the identity. And so that's why you would say that it's equal to x to the A minus B because the number of x's you have multiplied is A minus B number of x's. I think Delaney, that one was your question. Does that answer your question? Delaney, I saw that you unmuted, but I didn't hear you say anything. Can you try saying it again?
Yeah, sorry. I think I'm still a little bit confused, but I can rewatch it and it'll probably clear it up. Thanks.
No worries. Any other questions on this conjecture as a whole? I think we kind of touched on all 3 of these. Any questions on those? Okay, awesome. Then I am going to stop the recording and then I'll restart it for the second part of our office hours.